Hello and welcome to the Sound Engineering Project in Artemis Suite. I'm Wade Bray, Vice President of Head Acoustics and Technical Officer, and this is an amazing tool which has really an addictive quality to it, as well as being much more productive than video games, which are normally the thing you think of as having an addictive quality. So let's dive right in. The Sound Engineering Project is one of a set of auxiliary project types in Artemis Suite. It is part of ASM 19, Advanced Filters. It is a filter control system that enables you to work interactively in ways that have not been done before in our software or really anywhere else. The Signal Generator Project is another of the various auxiliary projects, ASM 21. The Compact Analysis Project for a very simple interface to Artemis Suite. The Decoder Project, ASM 24. The Calculation Project, the Automation Project, the Scala Jury Evaluation Listening Studio Project, and the Metric Project for developing composite metrics, also the Standardized Test Project. So what is the Sound Engineering Project? We're going to call it SEP from here on. What is it for, and what can I do with it? It's for modifying the sound you're hearing of your recordings. You can have any recording of anything, 2 channels, and with or without tachometers, and you see the sound's elements by interacting graphically with an FFT versus time, of which you can control the balance of time and frequency resolutions, and then you can do all sorts of interactive things by drawing and immediately seeing the result and hearing the result. Any intent, actually an intent, and an especially powerful use of the Sound Engineering Project is clearly with powertrain sounds, both IC and electric. We're having a lot of interest right now in the electric powertrain capacity, and this tool is particularly valuable in that area, as I hope you will see shortly. The picture in the Sound Engineering Project is the spectrum versus time of the recording. It may show, for example, transients, tones, engine orders, motor orders, modulations, resonances. You can play immediately what if. You can erase, you can get zones and lower the level of things in the zones, or raise them for that matter, replace what you have lowered with noise from somewhere else that is resynthesized. You can airbrush, just like the airbrush used in photo studios. You can reshape things, remove or enhance resonances or regions in time or frequency, and use your vision to see when, for example, you have exactly canceled a resonance, and modify then the spectral levels, balances, existing orders. You can create synthetic engine or motor orders, shaft phase accurate or otherwise. If you don't have a pulse tachometer, you can still generate synthetic orders. But if you do have a pulse tachometer, you have exact shaft angle accuracy with the reference point on the shaft, even beyond the RPM that existed in a recording. For example, if you have 2 vehicles, and we're going to see this, where one is a target and you drop that in and you have that, the pulse tachometer with the reference point being the same between the two means you can simply draw the extension of the RPM in the file with an engine which goes beyond the RPM of the target, and you have exact phase reference, all by simple interaction. You can drop in existing order cut HDF files or tabulations from spreadsheets, either versus time or versus RPM, to try measured order or level histories. You can do things from models. You can calculate things in spreadsheets, put models in spreadsheets. You can save new or modified orders, etc. The effects of the changes, the designs, the redesigns, and the ideas are audible as they're being made. Sounds can be re-engineered instantly, decided on, saved, taken to Artemis Suite for further analysis, and measured. You can move back and forth among different steps in your workflow. You can take a snapshot at any point. Objective numbers can be taken from the critically important perceptually validated results. As mentioned, you can take them to Artemis Suite and do a lot of other things and find out psychoacoustic, advanced psychoacoustic, other tools. So the Sound Engineering Project is really a marvel technically. It's a real-time linkage of the graphic image processing with the audio signal filtering, generation, and processing. Your senses, linking vision with hearing, where you are in control of what you hear and see, and can use your vision to see things that immediately enable you to relate what you're hearing and make the right choices. It's really a remarkable thing. It implements your viewing and painting and listening in a simultaneous connection. Sound engineering projects use the video processors and memory of your PC system, not just for the video, but also for calculation, massively, and it's linked synchronously with the main PC CPU system. So you have to use, you don't have to, but you should, in order to use all the capabilities, use a very powerful computer that has particularly good video capabilities, high video GPU capability and memory. The minimum PC specifications are listed along with the information for the ASM19 toolpack, and there is a test program called the Head Performance Analyzer that you run in your PC, and it makes an evaluation. If you get a score in excess of 1, you can use all the features. If you have a score below that, not all of them are available, and typically the one that is not going to work if you don't have enough capability is the target order tool involving shaft reference phase accurate tachometers in generating target orders. So here is the target, the performance analyzer, and it simply runs. You run it, and you get an evaluation. So my laptop that I'm giving this webinar on is a pretty hot one, pretty high-powered, and it has 3 results. The Microsoft Basic Render Driver is the basic software driver, and it isn't good enough. It's below 1, so it fails. However, there are 2 others, and the Advanced Video GPU system gets a 6.7. So the highest result will be used, and it doesn't matter if the render driver failed, if something else also shown is in accordance with what's needed, that will be used. So in order to open a sound engineering project, you go in Artemis Suite to the editing page in your open dialog, and then pick sound engineering project. So we're going to look in the PowerPoint first at some of the features, and then we will do them again live in the sound engineering project. Seeing them in the PowerPoint will give you an orientation so that everything will make more sense as we do them live. So after you open a new sound engineering project, simply drag and drop a recording from the head navigator. Then you're asked in the dialog to select the 1 or 2 channels maximum that you want, and the tachometer, if there is a tachometer. Which one, if there's one of more than one. The time trace then appears with a tile above it that names the recording. It's in a row above the diagram, which is a left to right list of operators in an operating sequence. First operator is the file itself, and then you can do things like eraser, brush, IIR filter, IIR order filter, order generator, and target order, as we will be seeing. So to the right of the file name is a green plus sign that allows you to select from a list what the available operations are. So if we have a file without a tachometer, for example, we can see our sound engineering project. We drag in the file, acceptance drive failed, and we see its time signal. We see the name on the tile, acceptance drive failed. That's where we start. That gets the file into the sound engineering project. Then we click the green plus, and we get a list of things that we can use. Eraser, brush, IIR filter. Because there's no tachometer, there is nothing related to RPM or orders here. If we have a file with a tachometer, in this case a pulse tachometer, we get everything. Eraser, brush, IIR filter, IIR order filter, which you can use if you already have orders that have moderately good to good signal to noise ratio. Order generator, which can be placed over orders that already exist, or more particularly, you can generate orders that do not exist in the file. Target order, likewise, we're going to be seeing all of these. So here with the file that has no tachometer, the acceptance drive failed, we're going to build a sound engineering project. So we brought it in, dragged it in, then we clicked the plus sign, we selected eraser from the list, eraser, and we get then a spectrogram, an FFT versus time. There is a selector that enables you to choose the delta T time resolution, delta F frequency resolution balance in order to focus the lens. This is something I like to talk about in order to get the best view of the sound as you hear it, the time structure and the frequency detail that you need to show the image as you hear the sound. So here, for example, is a car. Someone gets in. There is a mouse belt, the old style mouse belt that would move automatically when you get in the seat and shut the door. And then there are some clicks, and then the engine is started and driven off. There is a turbocharger whine, and we go through the gears with a manual transmission. So let's carry on. We have an eraser operator, but we don't have any erasers yet. So we click this plus sign from the eraser operator, and we get an eraser control panel and an eraser. The eraser is automatically by default applying a 20 dB attenuation. It can also apply a noise from anywhere else that you want in the file that can be brought in at whatever level you like in order to fill things in to remove the emptiness if you attenuate something. So let's move and set this first eraser. When you get an eraser, it's on by default. If you double-click inside the eraser, it turns off and you get the sound as if the eraser were not active. That is really useful because you can see it in order to position the eraser. So if you double-click in the graphic box, it deactivates the effect. You can roll the mouse wheel in the upper field of the dialog in order to change the gain. So here we rolled the mouse wheel a little bit. We basically accepted the 20 dB, but we double-clicked in here so that the eraser is not functioning. At any time, you can play the sound using the player of Artemis Suite. If you double-click outside any eraser box, it cancels or attenuates according to the number in this field everything else, the whole world, let's say. So you can solo the world with the eraser or erasers erased, or you can solo individual erasers with the world erased, or anything in between. Erasing a structure can produce an emptiness, an empty sound, if the basic background noise is absent where you erased the annoying thing that you wanted to erase. So you can then click here, and you then get a noise zone whose width you can change and whose position in the file you can change. So I moved that over here, and we're going to do this all live so that you can see where you place the noise, and then the noise, if it is activated by clicking here, you can roll the mouse wheel in here and adjust the amount. The applied noise is resynthesized as a random signal from the spectrum at the source location of the noise, here, our noise source location. It does not matter if the eraser is wider than the noise source zone, or vice versa, or the same. Here we have too much noise amplitude, so we need to roll down and put some attenuation in here. So we rolled in maybe 16 dB of attenuation, and we have 20 dB of attenuation of what was being erased, and that sounds just right if you play the file. Incidentally, you can choose A weighting. There's an A weighting button in each of these tools, and you can also then move the dB chart. So for example, to go to lower numbers brightens up everything, so you can see the details that you're working on in an eraser better. Here are other controls. Maybe take a screenshot of this. It's a busy slide, but A weighting is a toggle. This A weights only the spectrogram. It does not A weight the results. You never would want to do that. But for the sake of seeing what you're doing while you're painting graphically and working with the filters, the A weighting can be useful. You can set a playback time range. We did it by graphic methods. And where's my mouse? I just have lost my mouse. That's interesting. I'll go back here. There it is. Okay. So set a time range. We can do that by the numbers here. We can set the playback time range to the eraser limits. You can set a playback time range, and it can be the same as the beginning and ending of the eraser. If you choose this button, you can then set the time limits of the noise location by the numbers, as I mentioned, or graphically. So let's do what we just saw live in a sound engineering project. So we're going to go to Artemis Suite, and we'll also add an eraser. So I'm going to go into Artemis Suite now, and we have already a sound engineering project in which I had dragged this file. So there is Acceptance Drive. We click the green plus sign, we choose Eraser. The spectrogram is calculated. I'm going to turn it up by sliding here, and we're going to play the file. So we're going to stop it at that point. Now let's get an eraser by clicking this plus sign. So there's an eraser. We can move it around. You see that it is erasing. It has 20 dB of attenuation. We'd like to put that over here and move it up, and it tells us a sign what the attenuation is. And we're going to click inside and move the eraser. And click inside, be sure that we're controlling just the eraser and not moving the whole graph. And now I'm going to go to the A weighting, which will help us to see things, and turn it up even more. If I double-click in the eraser, that would have been useful to position the eraser better, but double-clicking again activates the eraser. I want to have some noise, so I'm going to activate the noise zone, and I'm going to activate that so that it appears in the eraser. So I would like to get a noise from somewhere else. So as I move here, we're going to see the noise get resynthesized in the eraser. So I'm going to move it over here to an area after the vehicle returns to idle, after the driving is finished. And that is too much replacement noise level, so we'll roll it down to about that amount. It looks about the same as the noise elsewhere, and we need to have a little bit more attenuation of the mouse belt noise, and now we can play. And that all sounds plausible. So let's get another eraser and get rid of the clicks. So we can get an eraser, we can move it over here, double click in it so that we can see what's inside the eraser, position this one, whoops, click inside, come down to about here, get the end point and the beginning point, and now turn it on and attenuate. We need more attenuation here, so we'll roll down more, and then we'll get the replacement noise again, which is too strong. Back it out, and this looks about good, and we'll try playing the sound. All right, let's go back to the PowerPoint and see where we are. So we will go to slideshow mode, that's that slide, and go to snapshots, because you can take a snapshot, which includes the file as it is operated on by the operator at the time you took the snapshot. And let's see how that works. At any point in a sequence of operations from the beginning, the original recording, to the current condition in any operator, like we've just done 2 erasers, you can take a snapshot. The snapshot captures the time signal in its condition manipulated by the operator from which the snapshot was taken. For example, what we just did with the 2 erasers. By left-clicking on the snapshots tile, you can see the time signal, just like you saw the original one when you brought the file in, and it is as currently affected by that operator. If you click on that tile, then you see the original time signal, and you can then export it as an HDF file, for example. So above a snapshot tile, after you take the snapshot, you see the operated time signal save available as a button that you can make an HDF file from it. So let's have a look here in the PowerPoint again. So we had our 2 erasers like we just did. We take a snapshot by clicking on this. What happens next is a snapshot is made and is a tile. And it has above it the save and recall features for the HDF file. So let's see what happens in the next slide. By clicking the tile, you see the operated time signal. Compare that to the original. Click this one. So the next slide, and we can see that result. Now we're going to go to the brush tool. So we're going to show this in the PowerPoint and then do it live. The brush is like an airbrush. So we click, following the eraser operator that we've just been using, we click and we get the brush choice. It opens as a new operator. Note that the data set has already been operated on by the erasers. The sequence of operations is now obvious. Up in here at the top, we have the first file itself, then the first operator erasers. The next is the brush that we're going to do, and we can continue this. You can rearrange the sequence. You could, for example, put the brush before the eraser if you like. The spectrogram would update accordingly, but if you had taken any snapshots, they wouldn't change. Before you activate any operator, when you get the spectrogram, that is when you can change the balance of time and frequency resolutions in the spectrogram, which will affect your results. You may need to do that for various reasons. So if you have already run an operator, made a choice to do something, that gets locked out. So let's do the brush. It's like airbrushing a photo. Rolling the mouse wheel changes the diameter of the brush and the width of its swath over the picture of your sound. You can adjust different amounts of attenuation or even amplification. The edge of the circle is soft. It is faded into the surroundings in time, horizontal, and in frequency, vertical, so there are no edge effects, just like a photo airbrush. It's not a hard-edged circle. Hold down the left mouse key, move the mouse, and paint with the brush. Its default attenuation is -6 dB. You can change that. You can make more than one pass. There are some advanced settings for replacement noise, but we're not going to cover them in this webinar because they're rarely needed with the brush function. So let's try that live. We'll go back out and we will go into the PowerPoint and we will grab a brush. And again, we are in the condition that we left after the erasers. So these things have been erased. We can go, for example, again to the A weighting and turn it up more so we can see what we're doing. And we might like to set perhaps something like 5 dB of attenuation, or 4.5. Let's do minus 4.5. Just guesstimating here. And then get the brush, change the diameter, and we might then brush this out. And we might change the diameter and brush that out. Maybe we'd take a new snapshot. You can turn on and off an operator and hear the result. So for example, if we get a playback zone, which is this, and I have to leave the brush itself and get the normal cursor in order to set this zone, we can do something like this in order to play this file. So this is brushed, and we can turn the brush off, on. Okay, we rest the case about the brush. Let's now go back to the PowerPoint and continue. Let's use the IIR filter. This is a fixed frequency filter. We'll start with a new sound engineering project that has a different recording in it that has a low frequency fluctuating boom, like that. So we choose IIR filter. We see the spectrogram with the low frequency effects, a very annoying thing in the cabin of this vehicle. And we can choose the frequency of the brush by clicking the mouse in the spectrogram, holding down the control key, moving up and down to the frequency we want, and then clicking the mouse. And the level versus time at that frequency in the filter bandpass, which is planted in place, will be shown like this. So there is the filter bandpass. You can adjust the order. You can adjust the filter type, Bessel, Butterworth, etc. You can adjust a parametric bandpass, amplifying or attenuating a region of frequency, or a parametric high pass or a parametric low pass. And if you roll in this field, you set the bandwidth. So let's see what happens here. Remember this adjustability, and we're going to do it live and show you a reason why we would do it. So we can, for example, simply draw a line. And this is going to demodulate that. We don't have to create an elaborate filter where we have attenuation where there's a maximum and amplification where there's a minimum. Just draw the straight line. And if you have the bandwidth correct and the resolution correct, you will demodulate this. It's really quite remarkable. So let's see what happens if we do this live in Artemis Suite. I have to go to Artemis Suite and get a new project here. So I'll close my first sound engineering project. We're finished with it. And get a new one. And that is in the SEPs column here, Sound Engineering Projects, and it is Low Frequency Fluctuating Boom. And I already have the file in. It's telling me I don't have a tachometer, so that's good. I don't need it for this. So we select IIR filter. And we have not made a choice here yet about the resolution. We can see what that does. For example, we have 85 milliseconds time, 5.9 hertz frequency. Let's go to more frequency resolution. Now we start losing the time detail about the effect. Let's go to 43 milliseconds, and now we have not enough to really see what the frequencies are. So I'm going to show you a trick that I like to use in this kind of situation. We get the best result for looking and finding the frequency. So we see here, and we can look here with the mouse and pick a frequency band, but we see roughly that we are at about, we can zoom here for example, and we are roughly about 40-something hertz. So now, if we go to one click more time resolution and less frequency resolution, it helps us, it's going to help us to make this filter. So we're going to use the filter, and we click the mouse to tell the computer, here we are. Now we hold control, and we get to where we see the issue, which is about here. And we click, and there is our bandpass. Watch what happens. If we now simply draw a line, that was a little too high in frequency, so it will actually demodulate. We can play the sound without the filter active. I'm going to speed this up. You can hear the beat. Now we've demodulated it. If I had the frequency slightly lower, we would have completely demodulated it. And there we are. So that is, I think, the last of that one. Let's go back to the PowerPoint and carry on. The IIR order filter, order generator, and target order. If you have filters, like the brush, the IIR filter as we've done, and the eraser, we're going to see how we can use spreadsheets and we can do relative gain or attenuation relative to unity gain 0 dB. So add some dB or subtract some dB of whatever is already there. If you generate orders, you have to use absolute value of the orders, dB sound pressure level, generate the order, modify the order. You can do that by order generator if you have any kind of tachometer, and you can do it by target order if you have a pulse tachometer, phase accurate. So let's go now to some actual data with two vehicles. We're going to start with a 1967 Jaguar XKE E-Type with the 4.2-liter dual overhead cam, inline 6-cylinder engine, 3 SU carburetors. I've driven both of these vehicles and they're quite wonderful. So we're going to start with the Jaguar in order to show some things with the IIR order filters. So let's carry on here and talk first about the 90-degree V6 engine, because we're going to be coming back to that in the Citroën SM. Then we're going to do a little live work starting with the Jaguar. And 90-degree V6 is not the ideal included angle between the banks. It is expected to be 60 degrees, but there have been some wonderful 90-degree engines. For example, the Citroën SM is a Maserati engine, 2.7 liters or 3 liters with dual overhead cams, and the average order spectrum is strongly equipped with 1.5 order spacings. The 1.5 order is higher than the firing rate, and we see these spacings continuing. Here is the current Alfa Romeo Stelvio 2.9-liter turbo 90-degree V6, which is quite similar in the average order spectrum. And we can see the drives here going through the gears. These are the averages over that. Here is the Jaguar XKE that we're going to look at next. It's simpler. It also has the 1.5 order spacings, but principally to the higher orders from the firing rate, and the firing rate itself is very strong. So now let's go to a new sound engineering project and get that one. So we'll go back to the sound engineering project. We'll close our present one, and we will grab the Jaguar XKE sound engineering project. And we have here a tachometer that we're not going to be using. It's not the one with the shaft accuracy, so we'll go ahead. We're just going to use a ramp tack. So we will get an IIR order filter. And here we see, and we can play the sound. I need this to be at just a second, the 90 level here in order to be comfortable, and back to the normal playback. Interestingly, the second order appears when throttle is lifted between the two gears that were represented here. This is an internet sound. It's not a calibrated sound. So anyway, we're going to get IIR order filter, and we're going to, there are two ways, by the way, to use it, but we're coming to that in a moment. The normal way is what I showed before, where you click in the spectrogram, hold control, you see the cursor, and you step at 1/2 order spaces. You can go to much finer resolution if you type the number in instead. So here we simply line on the second order because we want to take that down where that bump occurs and the second order goes up. There's the bandwidth of the filter. And we are simply now going to draw this line, and we can turn it on and off, and we see what we just did. There is a little letter I in the diagrams, also in Artemis Suite, in the windows in Artemis Suite, telling you what you can do. One of them is set the offset. So for example, we could take the whole second order to a different level, but we want to work now on the third order, so I'll go to the third order. So we will get another operator here, and click in here, hold down control, and look for third order, because the third order, for example, is a little bit too strong. So we're going to, remembering what we just saw, if you do shift, click once to tell the computer we're here, shift, you get an arrow where you can, if you click the mouse, amplify or attenuate everything. So we're going to drop it at about 6 dB. So we can drop the level, we can play the file, turn it on and off. All right, those are things that we can do in the control of orders. And you can, of course, modify any order you like using the IIR order filter. Now, there is more. Let's go ahead back to the PowerPoint and carry on here. So we had set a range of frequencies. You can also change from logarithmic to linear if you want, for example, to see straight line orders or nearly straight lines, and so on. With control held and the cursor in the spectrogram, you see where you are, and you can center the tracking filter on it. When you click the mouse and then release, it's there, and you can simply draw and modify an order. And we can also control the type of filtering and the activities over here in that little control panel button. Here are some important notes before we go any further. As I mentioned, the usual way that you can set an IIR order filter is to click Control and simply look and select when you're there. You can also type the number you want in this field, and that does not restrict you to the order number. You can type to, for example, 0.01 order in Artemis Suite 13, 0.1 order in Artemis Suite 12 and earlier, and you can, in the target order that we're going to see, you can go in Artemis Suite 12 to 0.5 order, and in Artemis Suite 13, it's going to be 0.1 order that you can type in here at resolutions. So we drew and held, got rid of the rise in the second order at that point. We then lowered the third order, and we also could go to the sixth order and raise it, for example, and enhance the sixth order just a little bit. So the time file can now be saved by taking a snapshot as an HDF file. So that's very quick. Let me see where I am right now. I now want to go to the Citroen SM, so we'll get out of the PowerPoint. And that actually was a slide that I should have talked about spreadsheets, because we're going to use the Jaguar before we leave it. I actually closed it too soon. So let me go back here and talk about spreadsheets. You can have level histories from models or from numerical entry and or calculation in a spreadsheet versus either time or RPM. Via a spreadsheet, you can do things to an order like adjust different levels in different regions of the RPM or load history. You could, for example, add 2.2 dB from 1000 RPM to 3255, and you could subtract 3.8 from 3256 to 6600. This can be any degree of complexity that you can get in a spreadsheet or calculate or run from a model, or very simple. We've received questions like, how can I make different level adjustments in different places? And the answer is by dropping a tabulation from a spreadsheet onto the diagram. And how do I do it? As Julia Child said on The French Chef, well, this is it. So there you have the answer, and we'll do it right now live. You don't drop the document itself. You do a Control-C on a region of row and column, the row of time or RPM, and the column of level values, and you drop it in. For time, drop the tabulation into the level versus time sound engineering project window. That's what we've seen so far. You can also display a tachometer history, the RPM window. If you have a spreadsheet versus RPM, drop into the RPM history window. So we're going to do these. We've mentioned using amplification and attenuation for filters, and for orders you use absolute values. So let's go back now to Artemis Suite Live, and hopefully I still have it. Good. Okay, very good. So we are now going to get some spreadsheets. I believe I have the spreadsheet here, and we will do versus time relative for the eJaguar. So we're going to select the spreadsheet, and we're going to go from 2 seconds to 6 seconds and drop the level by 3 dB. We're going to do Control-C to copy that, and we're going to drop it in here, Control-V, and there we have it from 2 to 6 seconds. You can do an undo and a redo, Control-Z, Control-Y. So we can also do this versus RPM. Let me, now that we have that gone, let's display the tachometer history. Now let's get another spreadsheet, which I can close this one and go back to my spreadsheets and find the RPM relative for the eJaguar versus RPM. That's the absolute. I need the relative. So versus RPM relative to unity for eJag. Here we go. So 3100 to 3400 RPM minus 2 dB. Let's get that. Control-C. And we will drop it onto the tachometer. Notice this range occurs twice. There are two different gears that have that span of RPM. So if you just drop it in, Control V, it shows up the first time that occurs. However, if you set a playback range and you move the playback range to the new area so that the other parts are not included, and then drop it in again, it's going to affect where that it is now. So we got it in the first gear and in the second gear of the, actually this was third and fourth gears in this vehicle. So that's how to drop in things from spreadsheet tabulations with relative either to time or to RPM. Let's carry on now. I believe our next step is the Citroën SM and the target order. So we will first get get rid of this and get the Citroën SM. And this is a complicated one because this is a complicated sound. This is a remarkable car, and it has if you drive it gently, it's very peaceful and quiet and calm, very elegant, but if you put your foot in it, as they say, and crank it up, it has the quote-unquote Maserati racing history snarl, and was a very popular sound in this vehicle. Out of context, it's funny. It doesn't sound so great, perhaps, but in the car it sounds wonderful, and there are even modern comments about that. So let's play the sound, and then we'll talk about what we've got. A trick that I like to do is if I'm going to make operations, I like typically to get the operator without doing anything with it first as a comparison, and then do something. So if we do this, you can see that I modified certain levels, actually quite a few of the orders here, and we have the ability to adjust when we modified an order between the original level. Click in the order here. So that, for example, is the 1.5th order. Here is the original value, if I slide it down. And here, morphing to the new value. We simply took the 1.5 level down everywhere to a great degree. Here, if we click here, we see the third order, and we can turn the third order up or down. You can see it changing in the spectrogram. So at any rate, if we play the sound, we can turn everything off globally. That, or leave it active and compare by clicking the empty target order. We have a control for taking the world down and having only the orders. So these are target orders generated by the pulse tachometer with the rest of the sound. Okay, so we are now going to go in the PowerPoint to an electric vehicle example. So back to the PowerPoint. Shift F5. The Citroën SM, we use the target order tool to modify many orders, and you can individually morph between the original and the modified, any modification you like, whether by drawing, by numbers, or by spreadsheet on an individual order. Then you can take the world down or out and hear only the orders or add order. So we demonstrated that. Here is an e-vehicle powertrain. It's a Chevrolet Bolt, and we're going to dive in and have a look at that. So going back to Artemis Suite now. This is coming near the end of our webinar. So we're going to close the Citroën SM without changing, and we're going to get the Bolt basic starting point. So we have the Bolt and can play it. Wide open throttle. That's the real binaural recording. We can choose to use target orders, or we can choose to use order generator. In the interest of time, I'm going to show you an example that has already been operated on a couple of the orders. This, by the way, was wheel RPM. You can, in Artemis Suite, by using the mapping function in the filter pool, use the gearbox ratio, for example, 7.05 for the Bolt, and generate a motor speed tachometer from the gearbox ratio with the wheel speed input. I didn't do that this time, but one could. So I'm going to use an example. So if we use the example one, what I did was to use IIR order filter, and I did not fulfill a criterion for the use of the pulse tachometer at the beginning. So I have to start at the point here, and I set the window for the playback zone. So we have, for example, the 56th order relative to wheel, and the 141st order relative to wheel. We could calculate those. I think it's 8, 12, 16, and 20 or 30th orders relative to E motor RPM at that ratio. So here's the sound with the modification. And we can turn it off, turn it on. We can morph the individual orders. Like, for example, things of this sort, listen only to the orders like that. And at any point, take a snapshot and be able to export the whole thing, or you can export here individual orders. So I'm going to wrap this up right now with an ending example of a high-performance powertrain we're allowed to demonstrate, but not say what it is. So I'm going to close this and go to the 05A 6-cylinder development. And I'm going to use a target order tool. And this is a high-performance twin-turbocharged V6 engine. The complaint was that it didn't have enough firing order tonality, the third order, to balance the high load, high RPM snarl, which was something they wanted to have, but not with the balance of not enough tonality. Here's the sound. This engine goes to very high RPM. So one thing that could be done, let's just do it for fun here because we can take this away, is we could use the airbrush to, and by the way, we notice here there is a very fine resonance. We could use an IR fixed order filter to drop that. We could bring the airbrush big, like this. We could do maybe a 2 point, let's just call it a 2 dB attenuation in the airbrush. And we can make this modification like, that's a +2. I didn't want to do that. So let's get rid of the airbrush and do it again. Brush, I wanted a -2. So brush size -2, and then brush this out like that, and it calms the sound down. You can say, well, what if I had a little more damping and was able to attenuate those results? What would that sound like? So there's an airbrush example. But let's get rid of this brush, because the point I wanted to make here was about the target order. So if we get rid of the brush, go back to target order, say we want target order 3, it calculates. We hold down, we get the spectrogram, we find the third order, and we click, and we simply draw more level through this region. And now we have a more plausible history of what was wanted with this sound. There is also a target engine. It was a different vehicle, similar powertrain, that had a balance that the developers of this one liked. So we're going to get that example. And we're going again to use target order. And we're going to look at the third order, control, find the third order, there it is. And there are two little things we'd like to fix. There's a hole here, and there's a hole here, and there's a slight drop off toward high RPM that we might like to fix like that. So we can hear that. We can again morph anywhere between. We can take the world down, and we can here go to save the selected target order as HDF. So I already did that. So let's now go back to our development engine and get rid of this target order tool, for example. And I keep forgetting to hit the yes sign, so we'll get a new one. And we'll go to target order. We will pick the third order, and we're going to drop the saved one from the target engine on it. So there is the order 3. We're now going to get the target order, and I want to go here to, where is it? Bear with me, please. Sound engineering project. It should be, here we go, target order 3. So we'll open it, and it drops on, and there we are. And we can change, and this filled in what they wanted, but the target order engine ran out of RPM here. Well, we have pulse accurate tachometer, shaft position. All we have to do is draw in a plausible extension. So that is it. I would like to pop out back to the PowerPoint to complete this, and Shift F5 and go on. So we filled the holes in the target powertrain. We saved that order, the third order, and we drew fill-ins for those two little places. And now we go back to the development powertrain, we drop it on, and it's still phase accurate even though we're extending beyond the RPM that was encoded on the target engine, because both of those were recorded with pulse tachometers that reference the same shaft position. So you can go take orders between files this way and produce synthetic orders. You can use target order and reduce and erase an existing order, for example, attenuating to any degree you like, as well as amplifying. So there we have the extension. We also, in the actual work with the customer on this situation, were able to take out the very narrow, very sharp, strong 1300 hertz resonance, and there was also a slightly reduced level, a little bit wider bandwidth around 550 hertz. All of that can be done immediately, auditioned immediately, and exported by means of the sound engineering project. So that's it. I would like to offer any questions at this point, and we will also keep the questions open. You can contact me by email, wbray@headacoustics.com. I would be very happy to talk with you about this and work with any files you like, and so on and so forth. I think this tool is as addictive as a good video game and much more productive. There's nothing like it. It is a terrific tool for doing what-ifs. You can export actual data. You can use orders in producing models. You can take them into Artemis Suite, and so on and so forth. So I hope we've shown you some things about the sound engineering project ASM 19 of Artemis Suite. Thank you very much for attending today.